All right, we are returning to these statistics students exams from the first video of this unit. You know, with that poor person that got the 31 and then a couple people got A's and B's, etc. So we're going to talk about box plots. Box plots are another way of visualizing data. We did dot plots, we did histograms. I love box plots. Box plots are amazing and they're very useful and they're very informative and they look very simple and clean. So let's talk about how to draw a box plot. As a small side note, some books call this a modified box plot because it uses outliers, but it's the best kind of box plot in my humble opinion. So we're going to start by finding the 5-number summary and IQR. Okay. We just did that in the previous video, so you can go back to the previous one if you don't know how to do it. I would highly recommend pausing the video and trying to do this on your own. Okay. So go ahead and pause the video and then we'll see if you did it right together. All right, whether or not you pause the video, let's find the median. So there are 15. So that means there's going to be 7 on each side of the median. So 1, 2, 3, 4, 5, 6, 7. This is going to be the median. There should be 7 on the right as well. All right. Whoop. I don't know what I just did, but this right here's the median. Something really weird is happening right now. And so that's useful. Remember, 5-number summary is the minimum, first quartile, second quartile, aka median, third quartile, and maximum. All right, so what we're going to do is find all those values. So again, median is 82, minimum is 31, maximum is 100. It's always easiest to start with these 3. Now to find the quartiles, the first quartile, the third quartile, you ignore the median. And now we're just going to look at what is the median of this half of the data. So there are 7 points here. The median of this half is 70. That's the first quartile. And we'll do the same thing to find the third quartile. Again, we're excluding the median. Look at the upper half. What's the median of the upper half? 94. So that's 5-number summary. IQR is just the difference between the third quartile and the first quartile. So just subtract that out. It's going to be 24, right? Just the difference between these 2 quartiles. So we found the IQR, found the 5-number summary. Step number 1 for drawing a box plot, complete. Next is draw the box. So we do need a scale, and then we're kind of going to do a little number line, kind of like the dot plot, little number line, and then we're going to draw vertical lines at the median, Q1 and Q3. So we'll start with the number line. And again, let's say this is 30, 40, 50, 60, 70, 80, 90, 100. Like so. And now we need a vertical line at the median. So vertical line at the median, vertical line at 82. Let's say it's somewhere like that. At Q1, which is exactly at 70. And at Q3, which is at 94. 3 vertical lines like so. Connect these to form a box. Go back to kindergarten, Jason. Connect these to form a box. Good enough. All right. Label your horizontal axis and include the scale. We already did that. There you go. That's step 2 right there. We have a box. And the box has the median. And right, this is the median right here. This is Q3. And this is Q1. So even though we have a box, it tells us really good information about the data. Let's go on to the next step. Determine any outliers. So there's no real cut and dry method for determining whether something's an outlier. But the rule of thumb is what we're going to use here. The rule of thumb is just 1.5 times the IQR above or below the third or first quartile respectively. Okay, so if it's bigger than an upper fence, which is calculated with this formula, then it's an outlier. If it's smaller than the lower fence, which is calculated with this formula, then it's also an outlier. An outlier can lie on either side, right? It can be either really big or really small. So let's find our fences just using the formula. Q3, which was 94, plus 1.5 times our interquartile range, which we said was 24. And we can simplify that to find our upper fence. But while we're here, let's calculate the lower fence as well. Q1 was 70. Now, for the upper fence, we go 1.5 IQRs above. For the lower fence, we go 1.5 IQRs below. So again, it's going to be 1.5 times 24. And for each of these, we are going to use a calculator. And 94 plus 36. I should use a calculator. I'm going to mess this up if I do it in my head. We can have Google Sheets do it. We already did it, right? 94 plus 1.5 times the IQR is going to give us 130. The lower fence is going to be 70 minus the same thing. 70 minus 1.5, that's going to be 34. So these are the fences. What this means is anything over 130, and we're talking about scores on a midterm, so anything over 130 points is going to be an outlier. That makes sense. Over 130 or under 34 is an outlier. That's what this means. And again, this is a rule of thumb. So if we're actually talking about exam scores and there's no extra credit, anything over 100% would actually be an outlier. But this is a rule of thumb, kind of communally agreed upon by statisticians, way of determining outliers. And we don't draw these. So step 3 is just useful for the future, but we're not drawing any in step 3. This is giving us information for fences. Next is going to be whiskers. Actually, let's identify the outliers here. Any data outside the fence is an outlier. So let's look at the data and see, are there any outliers? Over 130 or under 34? There's nothing over 130, but there is something under 34. This is an outlier. So we're going to use that when we draw the next part of the box plot. So step 4, draw the whiskers. We're going to draw lines to the nearest data value inside each fence. It's kind of a weird way of phrasing it, but it just means to the smallest or biggest thing that's not an outlier. Smallest or biggest, not outlier. Okay, and then we're having a short vertical bar. So let's find add a short vertical bar, the smallest and biggest thing that's not an outlier. So the biggest thing that's not an outlier is 100. So small vertical bar at 100. The smallest thing that's not an outlier is 62. 31's smaller, but 31's an outlier. The smallest thing that's not an outlier is 62. We're going to do a small vertical bar right there. And then we connect them, just like so. We're almost done with our box plot. So this is kind of like almost a minimum right here and almost a maximum, but it takes care of outliers, which is why it's really nice. That's why it's called a modified box plot. And then all the outliers are going to be the data values outside the fence. We're looking here. We're looking here. All the outliers we're going to draw with a dot or an X. The notes say to do a dot. Some places do an X. You can do either one. So the outlier was a 31. We go over here to the 31, and you can draw a little dot here or an X. And that's your box plot right there. It shows a bunch of meaningful data. It shows kind of what our realistic minimum and maximum is, as well as our 3 quartiles. It shows the interquartile range. That's this area right here. How big is that area? Then it shows kind of how far is the other data away from that middle. It shows some really good stuff. And as you work more with data, like especially in like if you go into the natural sciences, you're going to see box plots everywhere. When we're looking at studies, box plots, box plots, box plots. These are good ways of showing data. So let's write a paragraph describing the situation. We can talk about the shape, the center, and the spread, and any unusual features. Kind of looking back at that previous example. So let's answer this, but let's kind of zoom out a little bit so that we can actually see things. So something that I might say is let's, I think we can type like this. I'm going to type our answer. So describe a bunch of things. I covered up what I needed to describe. That's not very helpful. All right. Describe the distribution, talk about the shape, the center. So as you can see, the center, that has to do with this middle line. That's the median, okay? So the median was an 82. The median test score was an 82. Let's talk about the shape. And we could say most of the scores were between 70 and 94. Because most of the things, that's the middle 50%. Okay, that's going to be Q1 and Q3. And we could talk about the shape a little bit. I don't think the shape is mostly unremarkable. But there's an outlier with an exam score of 32. Maybe they're planning on dropping the class, or maybe they didn't study, who knows. But it's an unusual score. I don't need to speculate on it here, but that's all it's kind of going for. So again, as a review, we've said this many, many times. I'm going to say it again. If it's skewed, we use median and IQR. If it's symmetric, we use mean and standard deviation. And it has to do with outliers and skewness. Outliers and skewness really screw up mean and standard deviation. So if we have those, that's when we talk about medians and IQRs. All right, good luck. Feel free to continue preaching the good word of box plots because I love them. I hope you like box plots too. If not, we'll use them enough, and I guess if not, it's fine. You don't have to like them as much as I do, but they're great. Okay. Let me know if you have questions, and good luck.